Hello everybody and welcome to a new video on this channel. It has been a long time since my last upload. Sorry for that, I've been quite busy. Today I will show you how to plot a probability density function into a histogram plot. So why do we need it? Imagine the case that we have a vector containing random numbers from a certain distribution. Let's say a normal distribution with the specific mean value and the specific value for the standard deviation. What we normally would do is calculating the histogram, and then we would see the probability density function approximately looking like a Gaussian distribution. And in some cases we also want to add the continuous probability density function into the plot. As a reminder, if we are talking about random variables, we can describe them using several functions. The most important functions are the probability density function and the cumulative distribution function. The relation between both functions is that by integrating from minus infinity up to infinity over the probability density function, we will get the cumulative distribution function. The histogram is a discrete approximation of our probability density function. And by cumulative adding up the histogram bins, we would also get our discrete approximation of the cumulative distribution function. But today we will generate a vector containing random numbers derived from a normal distribution with a specific mean value and a specific value for the standard deviation. Then we will calculate the histogram, and then we will generate the continuous probability density function according to the normal distribution. And so let's directly head over to our workspace, and we start by closing all maybe opened windows, clearing our variables and clearing our command window. And because we are using statistical functions here, we load the statistics package from GNU Octave by typing package load statistics. For sure you have to pre-install the package, and then you can load it with the command here. And the first thing that we are going to do is to define a mean value of our random variable following a normal distribution. Let's say a mean value of 5 and a value for the standard deviation of, let's say, 2. I'm not using STD for the abbreviation of standard deviation because this is a built-in command in order to calculate the standard deviation. We will see it later. And then we have to define the amount of samples that we want to generate. Number of samples. Let's say for a nice statistic, we will take 10,000 samples. We will not reach the central limit theorem here, but 10,000 samples should give us a nice view of the distribution in the histogram. So then we are generating our random numbers from a normal distribution by typing or using the norm random command, norm RND. This command accepts the mean value, the value for the standard deviation, and the number of samples that we want to generate. In our case, 10,000. So, number of samples. Just fire it up to see if we made any errors. No, everything's correct. So, now X is a vector containing 1000 random numbers derived from a normal distribution with the mean value of 5 and the standard deviation of 2. And to see if we have made any errors or if we really have generated random numbers following a normal distribution, we will have a look at the histogram. Not Instagram. Instagram will not tell us the probability density function, but the histogram function. And therefore we type hist and we pass our random number vector to our histogram function, and we also pass the number of bins to the histogram. Let's define it here, number of bins. Let's say 100. The histogram function is calculating how many, let's define it from the other way. The number of bins are dividing our value range that we have inside our random vector x into 100 bins. So into 100 intervals. And the histogram function is calculating the amount of numbers from our vector x that are falling inside each of these 100 intervals. This is the variable counts. So now we have calculated the counts per bin, and this is an absolute value. For example, in counts we have for bin 1, let's say 10 samples, then 20, but we want to have it relative. Therefore, I will normalize the counts by its sum. And the reason for it is, if we are looking at the probability density function, if we integrate over the probability density function, the overall area is 1, because for sure the probability from minus infinity up to infinity in the continuous way that our value will occur is 1. And in order to be able to plot the histogram and the probability density function into the same plot, we have to normalize our histogram. And we do it by taking the counts and dividing it by the overall sum of counts. And if we now have a look at the sum of counts, it's 1. It's normalized to 1. So, okay. So now let's plot our histogram. Therefore, we use the bar command, and the bar command accepts x and y values. And our x values, our x-axis in the histogram are the bins, our intervals, 100, and the corresponding counts, our normalized counts. And we give a label to the axis. Let's call it x-axis are the bins, and the y-axis is called labeled counts. And we turn on a minor grid because the plot looks nicer. So let's fire it up, and I will show you the figure. I'm still not that familiar with OBS. That's the reason why I haven't configured any shortcuts yet, and why I need some seconds in order to show you the... So here it is. Here you can see our histogram plot of our vector containing random numbers from a normal distribution with a mean value of 5. We can see that the mean value here is approximately roughly approximated 5, and that the standard deviation is 2. But we can also use the built-in tools in order to verify the mean value and the standard deviation. Therefore, we are heading back to our workspace, and we can calculate the mean value of our random vector x mean, and the mean value is 4.9969, so yeah, it's 5. And the standard deviation can be calculated using the std command. That's the reason why I used s for as the abbreviation for standard deviation instead of std. And the standard deviation is 2.0120. So yeah, as desired. So with our histogram, our normalized histogram, I will add a command here. Normalization. So, and now we want to generate the continuous probability density function corresponding to the values that we have chosen here for our normal distribution. And I call this vector xpdf. And to generate the probability density function values, we are using the command norm pdf, normal probability density function. And here we have to pass 3 values at least. The first are the x values at which the probability density function should be evaluated. And the x values are our bins, because this is the x-axis in our histogram. And then we have to pass the mean value and the standard deviation of our desired normal distribution, because we want to generate the probability density function of our normal distribution. Okay. So, and now we are doing the same as we did for the counts from the histogram bin. We are normalizing the y values by taking the vector xpdf and normalizing it to its sum, xpdf. And if we are now typing sum xpdf, it should be equal to 1. Perfect. The same for the counts. And now we can plot our probability density function also into our histogram plot, and both curves should be aligned properly because of the normalization. So therefore we use the plot command. We have a continuous function here, and we are plotting x against y, and x is again our bins vector, again our 100 intervals of the value range from x, against our y values, which are our evaluated probability density function, which are the values evaluated at our bins. So the probability density function evaluated at the bin points. And we will add a legend to our plot. So in the legend we have to sequentially type the names. So the first plot was histogram, and the second plot is PDF, histogram and PDF. And let's fire it up. Maybe I should change a more recognizable color for our probability density function, in this case red. And let's fire it up. Yeah, now we can see it clearly. So, and I will show it to you. So, and here it is. Again, our histogram plot in blue, and we see our probability density function in red. Yeah, and that's it. So it's an easy way to visualize the distribution of a random variable. And when you're dealing with data analysis, statistical data analysis, you will often need such visual representations. So yeah, that's it. Short video. I hope you enjoyed it, and we will see us the next time. And I will try to increase the upload frequency of my videos, and hopefully we will see us within the next days. Bye bye.